so let's start then. Have you tried solving the questions yourself? Yeah? Okay, good. Okay, so the first question is a tank of water. It initially has water inside the tank, initially has the height of 9 centimeter, and then you move it to the right hand side with an acceleration equal to 5 meter per square second. So because of this acceleration, now the free surface of the water is no longer horizontal, but it has a deviation like this. And we know that the distance here is equal to the distance here. The L is 24 centimeter, the width of this tank is 10 centimeter, and you are asked to, what will the water depth be on side AB? This is side AB, the left hand side, and you want to know the depth of the water. So we know that initially the height was 9 centimeter, and now it is increased with the amount of delta D. Okay, so to solve this, we need to use this equation. F is equal to MAX. M is actually equal to rho V. Hi. M is rho V. And we know that the V, which is the volume, is equal to HLW AX. I am taking this control volume here. The pressure here is P1 and the pressure here is P2. And what else? The height of the water here is also D1. Okay? So that's why the volume of this control volume here is equal to HLW. The H is the height of the control volume. This is the H. Okay? So now let's go to the F side. We know that F for the hydrostatic force is P multiplied by the area. And I can write it as P1 minus P2 multiplied by the area, which is WH, this is the area, is again equal to this side of the equation, rho HLW AX. Okay? And this P is the hydrostatic pressure, which is equal to rho G D1. P1 is equal to rho G D1 and P2 is equal to rho G D2. And here is D2. So I have rows in both sides. I have W and H.
Sorry, could you repeat that?
Sorry. I tend to forget that. Just remind me, please. So we have rho W and H in both sides, so they cancel out. And using this, you would get D1 minus D2 equal to LAX over G. And this is equal to here, L is 24 centimeter, so 0.24 multiplied by AX, that in the equation, in the question is given to us as 5, and G is 9.81. And this is equal to 0.122 meter. And D1 minus D2 is equal to 2 delta D. So delta D would be equal to half of this amount. And to calculate D1, we need to add the 9 centimeter, which was the initial height, plus the delta D. So D1 is equal to 0.09 plus by 2. That would give us D1 equal to 0.151. This is the first half of the question. In the second part, you are asked to calculate the pressure force. The pressure here is due to the hydrostatic pressure, and because the height of the liquid on the AB side is not, is changing, so you would use the integral from 0 from here to D1. This is the region you are integrating over, D1. And now, okay. So the force that we want is the pressure multiplied by the area. So area is WZ, and the pressure would be rho G dZ. This is area, and this is the pressure. So if you integrate this, rho GW is constant, but Z is not. So you would have this from 0 to D1. In that case, the pressure force would be rho GW D1 multiplied by 2. Now you have everything. You have the density, you have the gravity, you know the W given to us in the question as 10 centimeter. So, and we already calculated the D. So the pressure force is equal to 11.2 Newton. Any questions? Hi. Okay, so then let's go to the next question. The second question is, you have a petrol pump that fills a 75-liter tank in 1 minute. So 75 liter in 1 minute and 10 seconds. The diameter of the pump exit is 3 centimeter, and you are asked to calculate the average pump flow velocity in meters per second. Okay. So by giving this expression to us, 75 liter in 1 minute 10 seconds is actually giving us the Q. Q is equal to, but we need to change the liter to cubic meter because we need the cubic meter per second. 75 liter is equal to 75 multiplied by 10 to the power of minus 3 cubic meter, and it's getting filled in 70 seconds. So the Q is equal to 1.07 cubic meter per second. And on the other hand, we know that the Q is calculated by multiplying the area by the velocity, and the velocity is what we want. So the area is PR2, and the velocity comes here. So now you have everything but you would be calculated as 52 meter per second. That's it. Any questions? Okay, so now the third question. You have 2 inlets and 1 outlet in a pipe, and the diameters, the specific gravity, and the velocity of different sections are given to you. Assuming that the 2 liquids are thoroughly mixed within the chamber, calculate the exit velocity and a specific gravity at section 3, that is here. Okay, so by using the continuity equation, we know that Q1 plus Q2 would be equal to Q3, and Q is equal to the area multiplied by the velocity again. So A1U1 plus A2U2 would be equal to A3U3, and we have everything in the question. A1, U1, A2, U2, and A3 is given to us, so we can easily calculate the U3. And yes, thanks. U3 would be so U3 is calculated equal to 5.375 meter per second, and then in the calculate the exit velocity and the specific gravity at section 3. So we have the exit velocity now, and we need to calculate the specific gravity. Okay, now using the mass conservation law, we know that rho 1 A1 U1 plus rho 2 A2 U2 would be equal to rho 3 A3 U3. In the previous section, we calculated the U3, and the densities of the liquid in the section 1 and section 2 are given to us. Now, again, we have everything but the density in the section 3. So we can calculate the U3, the rho 3. The density would be 922 kilogram per cubic meter, but the question is asking you about the specific gravity. So to calculate the specific gravity, you have to divide this 922 by the density of water, which is 1000. So the specific gravity would be 922, which is dimensionless. Any questions? Okay, so I'm going to solve the next question. Question number 4. I want you to stop writing and just pay attention to what I'm doing, because this question needs more attention compared to the other questions. And this is an unsteady system with variable density, okay? So we have a tank filled with air. The initial density, the pressure, is given, and the pressure is given to us. And then this tank is being evacuated by the vacuum pump. So the volume of the tank is constant and is equal to 1 cubic meter, but the density of the air inside the tank is changing as we evacuate air. And then it says that the pump evacuates 0.0013 cubic meter of air per second regardless of the pressure. So we have the Q of the outlet. The process is isothermal, and for an ideal gas such as air, this means that the pressure over density at all times is constant. D in the question here is referring to the density. So the pressure over density at time 0 is equal to pressure over density at all times. And what you are asked is to derive an equation that shows how the pressure inside the tank P changes with time. And then use that equation to calculate the other part of the question. So what we have here is a tank. The density is 1.2 kilogram per cubic meter. P0 is 100 kilopascal. The volume of the tank is constant and is equal to 1 cubic meter. So the air is evacuated here. The Q is 0.03 cubic meter per second. And we know that P over density at all time is constant. And you need to derive an equation for the pressure that varies with time. Okay. So again, using the continuity equation, I know that the mass that is coming to this tank minus the mass that is coming out of this tank is equal to the rate of accumulation. Nothing is coming to the tank, so m dot in is equal to 0. But we have the air coming out of the tank, so m dot out is not 0, and by multiplying the density by the Q, you would get the m dot out, and it's showing the change of the mass inside the tank by time. And you know that the mass is equal to density multiplied by the volume, so the volume is constant, comes out of the differential. You would have d rho over dt. Do you understand it to this part? Because the rest of the solving is purely mathematical. The fluid part is this part, that you can use the continuity equation to understand, to derive this. So now we integrate this. This dt comes to the other side, and we would have d rho in the another side. Minus q over the volume multiplied by dt is equal to d rho by rho. Because you have d rho on the right hand side, you have to bring the rho to the right hand side when you want to integrate. And now if I integrate this, I hope the q is constant, the v is constant, so dt after integration would be t, and the d rho over rho after integration is equal to ln rho plus a constant. And I need to calculate the constant first. To calculate this constant, this a, I have the data for the initial state. I would use those data to calculate the a. So at time 0, the left hand side would be 0 because t is 0, and I would have the natural logarithm of rho plus a. So a is equal to ln rho 0. I can rewrite that equation now with knowing that what the constant is. So minus q over v by t is equal to ln rho minus ln rho 0. And you know that this is equal to ln rho over rho 0. And from the initial state, we know that rho over rho 0 is equal to p over p0. So coming back here, I can rewrite this as p over p0. The final form of this equation would be e to the power of minus q over vt is equal to p over p0. Okay? This is the pressure that is changing by time, and I can calculate the pressure over time. So in the second part is asking me, okay, so now if the pressure is equal to 1 kilopascal now, initially it was 100 kilopascal, now it's down to 1 kilopascal. What's the time? So if I use this above equation and the P is now 1 kilopascal, the initial P was 100 kilopascal, and now I know the Q, I know the volume, I can easily calculate the T. So, sorry. So T would be equal to 3,542 seconds. This is an unsteady question. So far you have worked with steady questions. So we have the time inside the equations, and because of that we cannot use the usual forms that we use. We have to go back to the continuity equation and start from the beginning.
How you get the continuity equation of that?
Oh yeah, okay. So did actually anyone stop writing and pay attention to me when I was solving this? No? Okay. Okay, so if I go back to the beginning, we know we have a tank here, and nothing is coming to this tank, but we have something coming out of the tank, and the flow rate of that outlet is given to us. The volume of this tank is constant, so the effect of this outflow is on the density of the air that is inside this. How can I write the continuity equation? In general, we know that what's coming inside the system minus what's going out of the system is equal to accumulation on the system. I use that to solve this equation. So m dot in, what comes into the system, minus m dot out, what comes out and what goes out of the system would be equal to accumulation. Accumulation is actually dm over dt, the change of the mass during the time. M is the mass, okay? So nothing comes into the system, m dot in is equal to 0, and m dot out is equal to rho q. You know, I can add something here. Q is AU, and m dot is rho AU. That's why you see that m dot as rho q, because this AU is actually q. So 0 minus rho q is showing me the accumulation that is rewritten as the change of the mass during the time. And I know the mass is equal to volume multiplied by the density. The volume here is constant. The tank has a constant volume. I take the volume out. So I would have d rho over dt. This is basically where this equation comes from. And if you rewrite this in this form, you have to rewrite this in this form because you want to integrate at one side of the equation you need dt, and the other side you would need d rho. And the rho is changing, so you have to bring the rho to the side that you have d rho. That's why we reform this like this, and then you are good to integrate. Q is constant, V is constant, so the integrate of this part is just t, but in the other hand you have rho that is changing, so the integration would be the ln of rho plus a constant. Any questions? Yeah?
Sorry, can you repeat the part above the line where you, after you change it to Q over V?
This line?
No, 2 lines above.
2 lines above.
Oh, yeah,
Okay, before integration. Okay. So I have minus rho q equal to V d rho over dt. I have rho here, I have d rho here. I have to put this in one side. Rho comes to this side, and then I would put everything else in the other side to make the integration easier. So minus q over v dt would be equal to d rho over rho. I cannot show it here, but basically you're bringing this t to this side and then bringing this rho to this side. So now you can integrate. If you have an integrate here, q is constant, v is constant, you would only have dt, and the integrate of dt is actually t. That's why you see a t here. In the right hand side, rho is changing, so it's the integrate of d rho over rho from rho 0 to rho at any time, and that is the ln of the rho. And now we have this constant, and we need to figure out what this constant is, because in the second part of this question we need to actually calculate the time. To calculate this constant, you would use the data that you have from time 0. Time 0 T is 0, so this side is 0. The ln of the density at time 0 plus that A, so A would be equal to ln rho 0. Any questions?
So the Q goes to AU or AB?
Area by the velocity. It depends what you're using to show the velocity. Are you using U as the velocity or V as the velocity?
Okay.
Okay, so now let's go to the next question if you don't have any other questions. In the question 5, there is a tank. It has 2 inflows from pipe 1 and pipe 3 and 1 outflow from pipe 2. The velocity here is at pipe 1 is 6 meter per second. The diameter of this pipe is 5 centimeter. The Q from pipe 3 is given to us equal to 0.01 cubic meter per second, and we know the velocity in pipe 2 equal to 4 meter per second, and the diameter of this pipe is 7 centimeter. The pipe's diameter is D, the tank diameter is D, and is equal to 95 centimeter. So you are asked to calculate dH over dt, and the H is the height of the water inside this tank. Again, this is an unsteady state question. We have variation during the time. So the rate of volume increase inside this tank is equal to net volume flow rates into this chamber. So the rate of volume increase, how can I write it in mathematical equation? The rate of volume increase, the area of the tank multiplied by dH over dt, that is showing the velocity changes during time. And the net volume flow rate can be written as Q1 plus Q3 minus Q2. 1 and 3 are inlets and 2 is outlet, so it has a negative sign. So now I have everything. I have the diameter of the tank, so I have the area of the tank, and I have the Q3 directly used. For the other two sections, I can use the velocity multiplied by the area to calculate the Q's. And by having those, I can finally calculate dH over dt. So here, So the height of the water through time is changing, equal to 0.009 meter per second. Any questions?
Should it be minus 7 over 95 squared times 4 at the second last line? The end of it.
Oh yeah. Thanks. Okay then. Any questions? No? So question 6.
Sorry, like the last question, do you need to convert the centimeters into meters?
Yeah, you should do that, but here, because there's
Ratio.
this a ratio, it
Okay.
doesn't make sense. But
Thank you.
yeah, you're right. The best form would be to have consistency. So next question, question number 6 is saying that you have the flow between two parallel plates. Initially, the flow is coming to this space uniformly, so the u is everywhere constant in the beginning, but because of the effect of these plates, because at the further down the stream, their velocity is no longer constant, and you would have a parabolic laminar profile, and the u is given to you. So u0 is 4 centimeter per second, and then this, for the parabolic part, u is equal to az h minus z, and that is h, and h is equal to 1 centimeter. So find the expression for the constant a in terms of u0 and h. Do we have any volunteers? Anyone wants to solve this? I can help you. No? Okay. So to solve this question, the most important thing to consider is that the volume flow rate is constant everywhere. The volume flow rate, the volume of the liquid that is entering the channel remains the same through the channel. So how can I again rewrite this in mathematical form? The volume flow rate at the beginning is equal to h multiplied by u0. You have the width of the channel as well, but it will be cancelled out. Okay, so the velocity multiplied by the height of the liquid would be equal everywhere. After that, you need to again integrate because it's not constant. U dz. The dz from 0 to h is showing the h u0. So you have the equation for the u that is equal to azh minus z dz. And after integration, you would have a, pay attention that h is constant. So z is the only thing that is the parameter here. And you integrate from 0 to h. So the h u0 would be equal to a h3 over 6. Now you can calculate the a. The velocity at the beginning is 4 centimeter per second. That is equal to 4 multiplied by 10 to the power of minus 2 meter. And h is 1 centimeter. That is 10 to the power of minus 2 meter. So a is calculated as 2,400 and is dimensionless. In the question, it's asked that find the expression for constant a in terms of u0 and h. So this is the expression for constant a in terms of u0 and h, and using that, a is equal to 2,400. In the next part, it's asking you find the maximum velocity u max at the center line of the channel. One important thing for you to consider here is that the maximum velocity is at the center line. The question is not asking about this, but this is a good point. So in these kind of cases, we have the maximum velocity at the center line, as you can see here. The maximum velocity is here. So now we know that u is equal to azh minus z, and at the center line it means that the z is equal to h over 2. So u max at the center line is equal to a h over 2 h minus h over 2. Any questions?
Ask how to convert h cube to the velocity dot. Like, how do you do this step? Yes. And can I see the first question?
The first answer?
Yeah, answer.
What answers we uploaded online?
Well,
I don't know, I'm asking. What answers we uploaded? For the other
I can check it
tutorial.
for you. I don't know.
Thanks.
I want to understand about this. You know this the velocity here is higher than like near the boundary, right? The way I think is that the displacement from the center line decreases the speed limit. Is that correct?
Do you know developed region, underdeveloped region in this kind of thing? At some point, I think it will be actually mentioned in the next lecture. I'm not sure, but it will be covered. So, you're welcome. After some point in the tube, the flow velocity remains like this the whole time. Okay? So there you can say yes. But before that point, this parabolic equation is different. So you cannot say that the velocity here is equal to the velocity here is equal to the velocity here. Yeah. We have underdeveloped region and developed region. It depends which region you're talking about. This the question has given you this.
Oh.
Yeah.
Okay, thank you.
What is the answer is different
Point. Okay, sorry.
But we've used this to calculate it, and it is
It
right.
seems that it is, yeah, 3 times 3
I mean,
seconds is really
without the dot.
yeah. I think this is correct.
And also the equation is t in the denominator.
No, that's not in the denominator. It's not in the parentheses.
It's Q by V times E.
Times, yeah. It's not. It
Q
doesn't
by
have
V.
it's not on the parentheses.
But we calculated it using these numbers.
Yeah?
But it turns out it's 354 without the dot.
Without the dot, yeah.
So
I think
this is
this is like a comma. It's not a dot.
Oh yeah. Oh
Probably.
you got to change it.
Yeah.
okay. Thank you.
Welcome.
And also,
Yeah.
for this A,
Uh-huh.
should this be negative?
Yes. I think here is negative.
Yeah. I saw that.
Yeah. Thank you.
I don't ln rho over rho not equals to p.
In the question, it says that P over D is equal to P0 over D0, and D is the density, so I wrote it as the usual form that you're used to. P over D is equal to P0 over D0. So P over rho is equal to P0 over rho 0.
Euro equals to
Okay.
Okay.
And so rho over rho 0 is equal to P over P is 0. Yeah. Hi.
The answers will be uploaded.
Will be?
Yeah.
Oh, okay.
For sure.
Yeah,
But
thanks.
without explanations, it's
With-
only answers. Only
Oh,
answers.
okay.
Okay.
Yeah, thanks.
See you.
Bye. Hi.
Can I ask something about the lecture?
If I can help,
Yeah, I
I'm
just
not
want
sure.
to know why is it the original volume is base times height? Isn't it base times
This
height?
is the original volume.
Yeah.
So,
Why is it not
B
considered?
multiplied by
Why is it not considered with of
the
container?
W. Yeah.
Yeah.
I think it should be there, unless B is the area. Let's see, up to the point. No, B is not the area for sure. So you would have a W there, but I think they're because they cancel out, probably, or constant. joint to see what will happen. Yeah, you need that W, but because it cancels out, it has. Can I see the previous slide?
Oh, it's another. It's like a solution. You just use H instead of. Yeah, it's in the solution also.
In this one because
That's why I'm a bit confused.
volume BH the volume.